Here are some more inference flashcards for the AP Statistics exam. Remember, if you want to get a 5 on that exam, you need to know all of these flashcards. So the first one is conditions for chi-squared test. Okay, so these conditions are going to be the same for the first two. So random, you're still making sure it comes from random samples. For independence, you're still using the 10% condition. But for normality, for large counts, in order for this to be met, all expected counts have to be at least 5 or larger. Conditions for a t-test or t-interval for slope. Okay, for these conditions, you need to follow the acronym LINER. They were trying to spell liner, but LINER. Linear, independent, normal, equal variance, and random. So for linear, you have to describe the relationship. Is it a positive, strong linear relationship? Independent for 10% condition, same as usual. Normality, you need to be looking at the regression line and making sure that the responses form or vary normally, which means do you see a pattern or no pattern. Equal variance around the regression line for all x's, so is, again, you're looking at the residual plot and making sure there's no curved pattern. And then lastly, random, you're making sure that it came from a random sample or random experiment. Why do we check the random 10% in normal/large sample conditions? So random, we check these because in order to get a good representation of the population, the sample has to be random. 10% condition says, so sampling without replacement is okay, and we can use the stated formula for standard deviation. So we use the 10% condition to help us figure out if we're going to use standard deviation or an estimate of standard deviation. And then for the normal condition, it says sampling the distribution is approximately normal. So if it's approximately normal, it's easier for us to go through all these other things to solve. What is the difference between a parameter and a statistic? A parameter is the number that describes the population, and a statistic is the number that describes the sample. Remember, P, parameter, population. S, statistic, sample. What is the difference between the population distribution, the sample distribution, and the sampling distribution? A population distribution is a distribution of every single person in a population. A sample distribution is the distribution of responses for a single sample. And a sampling distribution is the distribution of all possible samples of given size from a given population. So every single person, one individual sample, many samples. What is the central limit theorem? CLT states that when the sample size is large, a sampling distribution of the mean of a random variable will be approximately normally distributed. What calculator function is used for a one sample t interval for mu? Well, this is the calculator function. Just note that on Desmos for a one sample t interval, we are going to be using a t-test after we click on add an inference. What calculator function is used for a one sample t-test for mu? On Desmos, it's still t-test. What calculator function is used for a one sample z interval for p? This is going to be a z-test for proportions. What calculator function is used for a one sample z-test for p? Still going to be a z-test for proportions on Desmos. What factors affect the width of a confidence interval? The width of a confidence interval decreases as n increases, so it's indirect, and increases as the confidence level increases, so direct. How do I make a decision based on the p-value? Okay, if the p-value is low, we reject that hoe. That's all you got to remember. What does it mean if we reject or fail to reject the null hypothesis? If we reject the null hypothesis, that means there is convincing evidence to support the alternative. Failing to reject the null means there is not convincing evidence to support the alternative. What is the probability that a specific confidence interval captures the population parameter? So it's either going to be 0 or 1. A confidence interval calculated from sample data either does or does not capture the population parameter. Don't say that there is a 95% chance or probability of capturing the population parameter. We just say that we are 95% confident. We always say we're blank percent confident. How to calculate expected counts in the chi-square test for homogeneity and independence. Expected counts is the row total times the column total over the table total. But if we go to Desmos and we click on chi-square test for independence under inference and we type in all of our data, what will pop up on those drop-downs are our expected counts and our observed values if you want to go and look through Desmos to find that instead. And then lastly, how to choose the right inference procedure. We need to ask ourselves the following questions. Is this a mean, proportion, counts, or slope? Okay. Then we need to ask ourselves, is it 1, 2, or paired samples? And then, does this scenario describe a test or a confidence interval? So those questions are going to help you determine right away if it is going to be a z-test or a t-test, a z-interval or a t-interval. Is it for proportions or for means? Okay. And if it's the other unusual ones like counts, we know it's chi-squared. Slope, we know it is going to be those regression lines.